The speedometer of Terry's Honda CR-V is designed to be accurate with tires of radius 14 inches. Find the number of rotations of a tire in 1 hour if the car is driven at 55 miles per hour. Okay. So if the car is traveling at 55 miles per hour, what does that mean in relation to the tires? Well, you can think about what's consistently touching the ground is the circumference of the tire. You can think about it like as the car drives, imagine the tire, it's like laying down its circumference. So what we want to think about is how much of the circumference of the tire was laid down if it drove at 55 miles per hour for 1 hour. So 55 miles per hour for 1 hour, that's 55 miles. The radius of the tire is 14 inches. So if the car drove 55 miles, how much circumference of tire is that? So we need to convert 55 miles to inches. One mile is 63,360 inches. So 3,484,800 inches. Okay, so how many rotations of a tire is this? Well, we know that one rotation of a tire lays out a circumference. That's 2 pi times the radius, inches. So the inches cancel and we're left with rotations. So divided by 2 times pi times 14. So about 39,616 rotations. Okay, suppose that oversized tires of radius 16 inches are placed on the car. If the car is now driven for 1 hour with the speedometer reading 55 miles per hour, how far has the car gone? If the speed limit is 55 miles per hour, does Terry deserve a speeding ticket? Interesting. So, people get their tires changed to bigger tires. So I'm assuming it's protocol when you do that the people who install the tires need to update the speedometer. So here we're assuming that the tires were changed, but the speedometer wasn't updated. So what does that mean? All right, well, the tire radius is now 16 inches. And the key here is to realize that the angular rotation, the total angular rotation of the first question is going to be the same here. So let's come back and get this. So this was 39,616 rotations. So what happens is that you can think about the speedometer is going to be reading the angular speed. And then I'm assuming like in the computer, you have to have like a factor that accounts for the radius of the tire. So the key here to answer this question is to realize that. So the speedometer is, you can think about it, it's indirectly tied to, if this is the tires, this isn't where the speedometer reads speed, but you can think about it like it determines the angular speed here. And you just need to put into the software the factor for the correct tire radius. And so For the 14-inch tires, it was calibrated correctly. Now, when you put on the 16-inch tires, and then if the speedometer is reading 55 miles per hour still, then it's still reading the same rotation, the same angular rotation here. So the angular rotation of the 14-inch tires and the 16-inch tires at the speedometer reading of 55 miles per hour are the same. That's not the case in general. That's the case if you didn't update the speedometer so it's calibrated correctly. Since you didn't update it, then when it reads for both cases, it's reading the same angular rotation. But you can see though, if it's for the same angular rotation but a larger radius tire, this is going to be going faster. Okay, so what's the angular rotation? And let's use radians because radians are result in simpler calculations. So 39,616 rotations. And that was in 1 hour. So 39,616 rotations. And then for every rotation, that's 2 pi radians. So about 6,305 radians. In that hour. Now the car with this tire is going to drive at that same angular rotation for 1 hour. It's going to go this many radians for that hour, right? So multiply that times 1 hour, and it rotates this many radians. So how far does at that many radians? How far does this travel in an hour? Well, S is equal to theta r. What's the arc? What's the total arc length? Right. This is like a bunch of rotations, but so it's like the amount of circumference laid down. That's 6,305 times 16. About 100,881, and that's inches. Okay, but we want that in miles. 63,360 inches for every 1 mile. $1.5. Okay, I messed this up. I divided this many rotations. You multiply that times 2 pi, not divide. So 39,616 times 2 pi. $248,915 radians. Okay, S is equal to theta R, so times 16, 398,263, 0. Inches. $63,360 inches for every 1 mile. $62.9 miles. Okay. Now, does the car deserve a ticket? Well, that's about 8 miles over the speed limit. So, you know, usually it's about I feel like it's 10 miles an hour over the speed limit. So I'm going to think Terry probably wouldn't get pulled over.